everyone, welcome to my channel. This is the part 2 video of regression analysis. Specifically, we'll look at solving numerical problems on linear regression using the least squares method. If you are new to my channel, please do well to subscribe and hit the bell icon to get notified each time I publish a new video. Thank you. And now, let's take a look at the question we have on the board. The data set below covers the age, of course, in years, and the corresponding weight in kilograms of 7 children obtained in a random sample. The question says, state the equation of line of best fit, also known as equation of lines of regression. Number 2 question says, use the line of best fit to predict weight of a child of 14 years. Number 3 question says, find the correlation coefficient and interpret your result. Let's get started now. The table here shows the ages of these children with their corresponding weight. Alright, first question says, state the equation of line of best fit. Part 1 of this video made it clear that the equation of lines of regression or the line of best fit is determined by the slope and intercept steps involved. Generate value for the sum of x. The sum of x simply means the addition of all the x values. That means adding up 1 plus 2 plus 3 plus 4 plus 5 plus 6 and lastly plus 7. That gives us 28. Summation x equal 28. Step 2 says generate value for the sum of y. This simply implies the addition of all the y values. We have 3 plus 4 plus 6 plus 7 plus 12 plus 18 and lastly plus 20 gives 70. 3 says determine the mean of x. Mean of x, the formula is summation x divided by n. We already have value for summation x. Our n value implies the sample size of the S series. We could get that by count, which is 1, 2, 3, 4, 5, 6, 7. N value is 7. Mean becomes summation x, which we had 28 over 7. And of course, 28 over 7 we have 4. Mean s equals 4. Step 4 says determine the mean of y. Mean y is designated with y bar equal to summation y over n. We already had value for summation y, which is 70 over sample size of y. We could get by count 1, 2, 3, 4, 5, 6, 7. Record that now. So, mean y becomes 70 divided by 7, which is 10. Step 5 says, generate values for x, y, and determine the sum of those values. This takes us back to our table. X, y simply implies the product of x and y. We title this series xy. For the first column, we have 1 times 3, which gives 3, followed by 2 times 4, 8, 3 times 6, 4 times 7, 5 times 12, 6 times 18 gives 108. Finally, we have 7 times 20, 140. Remember, the question went further to say, get the sum of those values. Sum simply means addition of these values. And here we go now. 3 plus 8 plus 18 plus 28 plus 60 plus 108 and lastly plus 140 gives us 365, and we record that now. Step 6 says generate values for x squared and get the sum of those values. Here we go now. Title this series x squared. X squared simply means locate the x series square of each of these values by multiplying it by itself. The first one, we have 1 square here, which is 1, and we record that now. 2 square, 4 here, 3 square, 4 square, 5 square, 25, 6 square, 36, and lastly 7 square, 49 here. Remember, the instruction is to add up these values. So we go 1 plus 2 plus 9 plus 16 plus 25 plus 36 and lastly plus 49, 140. We record that now. 7 says generate values for y squared and get the sum of those values. Title this row y squared. Y squared simply means multiply each of these y values by itself. First one, we have 3 square, which gives 9, followed by 4 square, 16, 6 square gives 36, 7 square, 49, 12 square, 18 square, 324. Lastly, we have 20 square, 400. Remember, the instruction is to sum these values, and here we go now. 9 plus 16 plus 36 plus 49 plus 144 plus 324 and lastly plus 400 gives 978, and we record that now. Summation y square equal 978. Remember we did say that the equation of line of best fit is determined by slope and intercept. Slope is denoted by b1 while intercept denoted by b0, right? Having said that, we're going to look at for b1 of x on y. The x here is the dependent variable while y is the independent variable. We're also going to look at for b1 of y on s. Here, y is the dependent variable while x is the independent variable. And here we go now. Part 1 video established that the slope of s on y is equal to sum of squares xy over sum of squares y. Sum of squares sy is equal to n times summation sy minus summation s times summation y, while sum of squares y equal n times summation y square minus summation y all square. On the other hand, for b1 of y on s, the sum of square sy equal n times summation sy minus summation s times summation y, while sum of square x equal n times summation s square minus summation x square. We're going to substitute all these values we've gotten so far into the formula, and here we go now. b1 will be equal to n. We did say n value is 7, and we record that times summation xy, summation 65, we record that now, minus summation s, the value is 28, times summation y, of course 70, and we record that now, divided by n. We did say n value is 7, times summation y square, we had 978 minus summation y all square. Summation y is 70, so we have 70 square here. Going forward, we have 7 times 365 of course gives 2555. We have minus here, 28 times 70 gives 1960 over 7 times 978, 6846. We have minus here, 70 square gives 4900. b1 will be 2555 minus 1960, and of course that gives 595, and we record that now. And 6846 minus 4900 gives us 1946, and we record that. b1 equal 595 divided by 1946, 0.31. So we succeeded in getting the slope of x on y, which gave 0.31. We did record that here. So we're gonna look at for slope of y on x. We did say the slope of y on x equal sum of squares xy divided by sum of squares x. Looking at the slope of x on y, we could see the similarity is sum of squares sy, while the difference is the denominator for this is sum of squares y. Here is sum of squares x. And so sum of squares sy will get 595 as its value. Record that here now. So we have over, we have n here, n value is 7. We record that now. Times summation x square, we got 140 minus summation x 28 all square equal to 595 over 7 times 140, 980. 28 square gives 784. b1 will be 595 over 980 minus 784 gives. Finally, the slope is 595 divided by 196, 3.0. So we succeeded in getting the slope of x on y and the slope of y on x. And now remember that we did say that the equation of line of best fit solely depends on the slope, that is the b1, and the intercept. And now let's proceed to getting the intercept of x on y and also the intercept of y on x. Intercept denoted with b0 of x on y equal mu x minus b1 times mu y. On the other hand, the intercept of y on x equal
mean y minus b1 times mean x. So we're going to substitute all the values we've gotten here into our formula. Here we go now. b0 equal mean x. Trace back our value 4 and we record that now. Minus b1. b1 in this context is the b1 of x on y, which we got 0.31. Write that now. Times mean y 10 and we record that. b0 will be equal to 4 minus 0.31 times 10 gives 3.1. 4 minus 3.1 gives 0.9. Therefore, the intercept of x on y is 0.9. And so let's look at for the intercept of y on s. b0 equal to mean y. The y value is 10, and so we record that now. Minus b1 of y on s 3.0. We record that now. Times mean s 4, and we record that here. b0 equal to 10 minus 3.0 times 4, 12. Therefore, b0 will be 10 minus 12. Of course, that gives minus 2. So therefore, the intercept of y on s equal minus 2. Generally, the equation of line of best fit of y on s is represented with x equal b0 plus b1y. We've gotten value for b0 of x on y and also got value for b1 of x on y. Basically, we're expected to substitute these values into the equation. Here we go now. b0 0.9 plus b1 we got 0.31 y. So we've gotten the equation of line of best fit of x on y. Let's also proceed to getting the equation of line of best fit of y on s. And here we go now. Generally, the equation of line of best fit of y on s is represented with y equal b0 plus b1x. Y equal b0, we did say b0 equal minus 2 plus b1 is 3.0 x. So we've gotten the equation of line of best fit for y on s, and the equation is y equal minus 2 plus 3.0 x. These two equations of line of best fit are basically used for making prediction. We succeeded in answering the number 1 question. Let's proceed to answering the number 2 question. Number 2 question says, use the line of best fit to predict the weight of a child of 14 years. Here we go now. Remember in our table, age is denoted with x, while weight is denoted with y, right? And of course, weight was the question s, and age of a child, of course, is given to be 14 years, right? So the ideal equation of line of best fit, which will be used to predict the weight of that child at age 14, would be y equal minus 2 plus 3.0x. Have y equal minus 2 plus 3 times 14. And going forward, we have y equal minus 2 plus 3 times 14 gives 42. And we write that now. So y will be minus 2 plus 42. Of course, we have 40 here. Therefore, the weight of that child at 40 years equal 40 kilograms. And so we succeeded in answering question 2. Let's proceed to answering question 3 now. Question 3 says, find the correlation coefficient and interpret your results. And here we go now. Correlation coefficient denoted with r equal square root of b1 of x on y times b1 of y on x. This takes us back to the values we've gotten so far, and here we go now. Looking at this now, we could see that b1 of x on y equals 0.31, and we record that now. We have 0.31 here times. Let's also look at for the value of b1 of y on x. b1 of y on x we got 3.0, and we record that now. 3.0 here. R will be equal to square root of 0.31 times 3.0 gives 0.93. So the coefficient of correlation equal 0.964. The interpretation of this is that age and weight have high degree of positive correlation. So we succeeded in answering all the questions right. Thank you so much for taking your time to watch this video. Please stay tuned for the next video where we use the deviation from the main method to solve numerical problem on linear regression. To motivate me to work harder, please do well to like this video, leave a comment, share, and subscribe to my channel. Bye!